Well, the objective of this lesson is to understand the basic concepts linked with the Poisson distribution. Well, this is the one of the fragment that talks about the discrete random variable. Um, so now, where is Poisson distribution applicable? Now, when you talk about the Poisson distribution, generally, it is where the time interval is specified. Now, for example, now receiving a call at a call center in an hour, or misprints on a page or a particular book, fishes caught in per day, and car accidents per month. Now, wherever you notice, all of these have got certain time duration. So wherever these kind of specific scenarios are applicable, we use Poisson distribution. Now let me just take an example. Now, for example, let's say a book publisher is publishing a particular book where he notices that he can make two mistakes on each page. So if each page he makes two mistakes, now what happens is that if I select 10 random pages, now 10 random pages of the book, so 10 pages. Now, if I wanted to check what is the probability that it'll have no mistakes, let's say zero mistake or one mistake or two mistake. So assuming if the data follows a Poisson distribution, we can use certain tactics that I'm going to discuss a little later to find out the probability of these events to occur. So let's just have a look at one proper example on Poisson distribution and some key concepts. Well, for Poisson distribution, if a particular variable follows a Poisson distribution, we write like x is distributed with Poisson with the mean of that duration. Now, for example, in the previous example that I gave, now I was discussing that in one page there are two mistakes. So if the mistakes follow the Poisson distribution, then I can write down that x is distributed with Poisson with the mean of 2. So this is a simple way of writing this. Now, how do I use this formula? Now, when I have been given that, okay, now the mistakes occur at 2 per page. Now I'm giving, let's say, a question that if I have been given, let's say, 10 pages of the books to analyze. Now, what is the probability that I find out, let's say, exactly 4 mistakes? Now, in that case, I'm going to write down the per page there, on an average, there are mistakes happening is 2. So on 10 page, I would expect that there are 20 mistakes. Now, how do I apply this formula? Now, for this time interval or this context, I'm going to say, okay, I wanted to find a probability of x equals to 4 mistakes. So the formula is the average of that duration, which is 20 to the power 4 times e to the power negative 20, that's your lambda value, which is the mean, upon the 4 factorial, that's your x value. So this is the probability for 4 mistakes to occur. So let's take one more explicit example on this that helps us to build up our key concept. Now here is the example. Let's say the number of errors Sandra finds while proofreading follows a Poisson distribution with a rate of 3.21 errors per page. Calculate the probability that on a randomly selected page, so randomly selected page, Sandra will find exactly 3 errors. Now here, the number of pages and the average that they have given here, that it is per page mistake. So, and here event is also for per page. So in this case, x is distributed with Poisson with mean of 3.21. Now I'm asking what's the probability for x equals to 3 mistakes. So we'll just apply the formula. The formula is probability of x equals to small x, that is lambda to the power x e to the power minus lambda over x factorial. So when I have got this as the answers, it is 3.21 to the power 3 times e to the power minus 3.21 over 3 factorial. This is the direct formula. So we get this answer as 0.22, and Now let's say they're asking at least 3 errors. Now at least 3 errors meaning no more than 2 errors. So what no more than 2 error mean is, so at least like 0 error, 1 error, and 2 error. So no more than 2 errors meaning I don't find any error, then I don't find 1 error, at least like exactly 2 errors. So it includes 0, 1, and 2 as the outcome. So same way you apply the formula, write down the probability for x equals to 0 error. That will be lambda to the power 0 into e to the power minus lambda over 0 factorial, and lambda being 3.21. Similarly, you substitute for x equals to 1 and you use calculator to find out this answer. Now, if you're finding out for more than 3, now for more than 3 errors, it means let's say 0, 1, 2, 3, and so on. And there can be infinite error also. So they want this part. If I have to find out, what I can do is I can just remove these values from 1 because these add up to 1. So that's what exactly has been done here. So probability of x less than or equals to 2 you find out, and then subtract from 1. So let's see how do we do the same questions on GDC. First for the A part, and then we'll go on to the B part. So let's have a look at on the GDC skills. So when you're finding out the probability for the previous question on GDC, so you can go on to the calculator, statistics mode, and then enter. Um, so go under statistics, you'll see this way. Then go under distribution, you go under Poisson. Then you have to select, if there is exact answer, then you select exact value that you want. Like for example, 3, then you select PPD. So let's talk about PPD. And now you take the x value as 3, and the average that you got is 3.21. And this answer we had got 0.22 earlier. So let's see, this is 0.22. Now when you want less than 2, something like that, you go under uh, distribution, go under Poisson, then go under PCD. It's cumulative. So lower value that I can take is 0, upper is 2, and the average is 3.21. So you can see 0.37 is the answer. Now when you want to find out more than or equals to 3, so when you want to find out more than or equals to 3, so lower is 3, and you don't know the upper value, so you can put a big positive number. So that's around 62% of the 62% chance that you will get more than 3 mistakes based on the data that they have given. Now for the B part here, now suppose that Sandra reads 10 page. Now here earlier the data was for 1 page where per page mistakes were 3.21. Now we have to do for 10 pages. So let's see what's the question. Now write down the probability distribution for this one. So for 1 page it is 3.21. So 10 pages it will be 32.1. So X will be distributed here with Poisson with 32.1. Find out the probability that there are at least 30 errors. So now let's when you say at least 30 errors means probability of X more than or equals to 30. So you're gonna just put this on calculator. Let's see how do we do this. So I wanted to find out probability for more than 30. So go under distribution, go under binomial, go under Poisson, go for PCD. Now lower value is 30 here, so 30, and upper value is a big number, so that's what you're gonna put. Your average changes to 32.1, so around 66% chance of getting that result. So here are 2 more examples on the Poisson distribution. Now, the question is, a supplier of clothing material looks for flaws before selling the material to the customer. The number of flaws follows a Poisson distribution with a rate of 1.7 flaws per meter. Find out the probability of exactly 3 flaws in 1 meter length. Now you're going to write down the distribution first. So X is distributed with Poisson with mean of 1.7 flaws per meter. Now, what you're going to do is you're going to find out probability of X equals to 3 here. And the next is at least 1 flaw in 2 meters. So for 2 meters of material, now X is Poisson distributed with mean of 3.4. And I wanted to find out at least 1 flaw. So x is more than or equals to 1. So what I'm going to do is I'm going to do the same thing now on calculator. Let's see how do we do that on calculator. So do follow the same stuff. You go under statistics, enter the statistics menu. You will notice you're here, distribution, go under Poisson, go under PPD for the first one. Now you got to first find out probability for x equals to 3. So when you're finding for probability for x equals to 3 with the average of 1.7, you get the answer as 0.14. Now the next step is probability, the mean has been increased to 3.4, and now the x value is actually different. We got to go in distribution, Poisson. Now you go under PCD because it's range of the x values. So put the limits. 1 is the lower, upper you don't know, and here average is 3.4. So your chance is around 96%. So this is how you do it on calculator. The next step is the find the mean and the variance and deviation of this distribution. Now, when you have, let's say x is distributed with Poisson 1.7. Now remember that the mean and variance of a Poisson distribution is the same. So the mean is 1.7, so is the variance. And as you know that the deviation is the square root of variance, so the answer is square root of 1.7 for this distribution. So this is how you do the questions on Poisson distribution. I hope this is helpful.